So, if you're paying attention, it says Unit 3. What happened to Unit 2? Well, when we brought in the flex block, I lost some instructional time and something had to go. And so I used to do a big unit on applying physics to graphs, and it was cool, but something had to go, and so I chucked the graphing section, which I know many of my colleagues would be horrified at, but something had to go. So Unit 3. Lesson 1, displacement and average velocity. First of all, in physics, everything that we measure is either a scalar or a vector. Anytime I teach you a new concept, probably the first thing I'll tell you is what symbol or letter we use to abbreviate it. The second thing I'll tell you is its units. And then the third thing I'll tell you is whether it's a scalar or a vector. Scalars have magnitude, fancy word for size, only. Scalars have magnitude only. For example, area is a scalar. How big is that field? 120 square meters. You don't say 120 square meters north. It makes no sense. Magnitude only, they just have size. Mass. You'll memorize these without really trying to, so I'm not going to say make flashcards or anything like that, but anytime I give you a new concept, you will need to commit to memory whether it's a scalar or a vector. Area we don't look at much in physics, but it's a scalar. Mass, time, work, energy, voltage, speed, distance. I could go on for a while. The key to realize the difference between a scalar and a vector, vectors have both magnitude, but they also have direction. Vectors have both magnitude and direction. Scalars have magnitude, but scalars have no direction. Much like your futures, no direction. Nothing. For example, velocity is a vector. Force is a vector. Momentum is a vector. Impulse is a vector. Lots. And again, you don't need to make this big list and memorize it. We're fine. We are going to make a small little list here, though. So, scalars and vectors. One of the ones I said was speed. For example, 30 kilometers per hour. That's a speed. Velocity, which is the vector version of speed, would be 30 kilometers per hour at 28 degrees north of west. That's a magnitude and a direction. So 30 kilometers per hour, then a little at symbol like in your email, 28 degrees north of west. Start out going west, go 28 degrees north of west, that's your direction. Time is a scalar. Force is a vector. Distance is a scalar. Displacement is a vector. Distance would be something like 12 meters. Displacement would be something like 12 meters due north. It says DUE. One of the easy ways, Riley, that we're going to show direction for vectors is instead of this 28 degrees north of west, that's physics 12 when we go two-dimensional, or instead of even just saying due north, we'll use positives and negatives. Positive will be forwards or up or right. Negative will be backwards or down or left. Although sometimes we'll let left be positive because it'll make the math easier. There's no rule that says down always has to be negative. We'll just usually go that way as a convention unless there's a good reason for doing something different. One of the other ones we're going to talk about an awful lot is acceleration. It's a vector. Little note, vectors are typically written in bold font, but this is hard to handwrite. Doesn't work well, and especially on my tablet, when I scribble back and forth, it tends to erase things. So when we handwrite a vector, the other preferred notation is we put an arrow above it to show it has direction. But Owen, over the years, we've gotten lazy and we only put the top part of the arrow. We don't actually even bother putting the bottom part of the arrow in. It's just we've gotten lazy over the years. So let me give you an example. This is a lowercase v. That's velocity. Look up for a second. Look up, everybody. That's speed. How do I know? Because there's no vector sign on it. Velocity, speed. Speed is a scalar, velocity is a vector. If I was a good teacher, I'd have a dumb way for you to remember that speed is a scalar. If I was a good teacher, I'm sure I could come up with a clever way for you to remember that speed is a scalar. Oh, and that velocity is a vector. There's probably an easy way to remember that, but I got nothing. You're on your own. You'll have to figure it out yourself. I'm a terrible teacher. So we want to talk about distance versus displacement. Distance is how far an object has traveled, and it's a scalar. Symbol. Don't write this first bit down. The proper symbol for distance is a lowercase s. Don't write that down. That comes from Isaac Newton. We hate it in physics because that s looks way too much like the number 5 if you're writing in a hurry, and it's also used for south and seconds. And so even though you'll see some old physics texts using an s for distance, we say, I'm going to choose not to. Don't write this next bit down. Really, the proper symbol for distance is the letter x. Don't write that down. Like on the x-axis, or if you're going up and down, the letter y on the y-axis. And yeah, but I gotta be honest, you can write this down. I just use a lowercase d for distance. Units, meters. Unless the question specifically says to measure the distance in another way. Displacement is an object's change in position. It's a vector. And this, unfortunately, I don't have a dumb, easy way for you to remember that distance is a scalar and displacement is a vector, because they both start with DIS and I don't have much of anything. So if you come up with something clever, let me know and I'll incorporate it into my teaching. I've just memorized it through brute force over the years. I know that distance is a scalar and displacement is a vector. Symbol, don't write this next bit down. Should be an S with a vector sign over it, but we hate that. Many textbooks in university will use an X with a vector symbol over it, but for me, I'm going to use D with a vector symbol over it. Its units are also meters. Pause the video for a second. When objects start moving, it's useful to be able to describe an object's location. To describe location, we typically imagine, like I just did in front of you, that a meter stick or a number line is placed next to an object. Usually objects to the right have positive positions. I will assume that's what you're doing. If for some reason there is a good mathematical reason to let left be positive, just make a note and I'll figure it out. And there will be later on this year situations where we absolutely let left be positive or down be positive, because it just makes the math way, way, way easier. And we're lazy that way. But for the most part in this unit, right is positive, up is positive, forward is positive. So here's a little number line. A bug is walking along this number line. It starts at A, walks to B, then turns around and walks to C. Let's even draw that. So it starts at A, it walks to B, and then it turns around and walks to C. That's its path. What distance did the bug walk? Well, the first little path that it walked looks like from A to B, which is how far in my little number line sketch there? 4 plus. Then it walked from positive 4 to negative 6, which is how far? In your head without a calculator, Annika? That's its distance. What's the bug's displacement or change in position? Well, it started here, it ended up there. Negative 6. Or you could write 6 meters left. Which one of those is less writing? But I won't take marks off if you write the other way. The only thing I'll say is don't say negative 6 meters left, because what would negative left technically be? I would argue it would be to the right. So use one or the other. Don't commit, okay? Example 2. Turn the page. Here we have path 1, path 2, and path 3. Along which path would your distance be different from your displacement? Let's reverse that question. There is only one path here where your distance and your displacement would have the same magnitude. Which one? Path 2. Yeah. So path 1, your distance would be, your displacement would be the zigzag. It would have a much larger magnitude. Path 3, again, your distance would be the straight line path. Your displacement would be that little, sorry, your displacement would be the straight line path. Your distance would be that wiggly path. Okay. So the long diagonal path would be your distance. The red line would be your displacement. Here, they're the same. Is that all right, Max? Yeah? Okay. Example 3. Positions. Says use the number line below to give the positions of the objects and don't forget units. What is the position of the heart? Don't forget units. Okay? How could you show to the right? Now, if you write 4 meters, I will assume that the positive is there. In our notes, we'll just throw it in there to remind ourselves we checked the sign. But you don't have to put that in your answers. Deegan, what's the position of the diamond? Yep. Meters. And what's the position of the cross? 0 meters. So if we have a position, we can use arrows to represent displacement. So for example, here is a bike moving along a number line from position of +4 to -3 meters. There you go. We often use a variable, x or d. I prefer d, but in the homework sometimes you'll see, because I'm stealing questions from the internet, they'll use an x for position. And we use subscripts, I for initial and f for final, to show initial and final. In other words, if I was labeling this particular bike, I might be tempted to call this x initial, and I might be tempted to call this x final. From the back corner, that lowercase I is sometimes tricky to see, so I'll almost always put a little curly tail on it and a big dot so you can tell it's an I and not a 1. Have it. What would the distance that this bike traveled be? 7 meters. What's its displacement? -7 meters. Or 7 meters to the left. Okay, not -3, because it didn't start, it started here. Look, initial. What's its change in position? Started at 4, ended up at -3. Its change in position is -7 meters. Can't assume that it started at 0, 0. Example 4 says, draw an arrow showing an object that moves from the -4 position to the +5 position. I'll freehand it. Ethan, what's this object's distance? Yes. What's this object's displacement? Again, 9 meters to the right, or what's a short way to write to the right? Are you positive? Nothing. Now, looking at this, you might say, Mr. Dewick, those are the same answer, except I know with the vector sign that there's an implied direction in the 9 meters. They both have the same magnitude. Unlike the examples that I was giving you where I was walking back and forth, generally, if there's a change in direction, the distance magnitude and the displacement magnitude won't be the same. But if there's no change in direction, the magnitude of the distance and the magnitude of the displacement will be the same. Just one will have a directional component. Example 5, draw an arrow showing an object that moves from the 7 position to the 1 position. Okay. Camille, what's this object's distance? Yep. Units? Yep. What's this object's displacement? Careful. Yep. Or you could say 6 meters to the left. -6, good enough. Let's talk about speed. So distance versus displacement. Speed versus velocity. Speed is a scalar. Velocity is a vector. Average speed is delta t over d, where delta means change in. Does anybody know what's change in anything always? Whenever you see that delta, that triangle, and you think to yourself, change in, what mathematical operation am I going to do? Now, if someone was clever, they'd be looking at the top right corner of their green sheet, and they would smugly know the answer to this. Kiana, what's change in anything according to the top right corner of your formula sheet? I think I left it on there. Top right, no, front page, top right corner. Isn't there delta equals Or isn't there a change in equals? No, above that. Maybe I took it off.
It's on the top left.
Top left? Oh, you know what? I moved things around. It used to be on the top right. Top left. What's change in anything? Change in anything is what? Loud and proud? Final. There's something between them that No. There's a mathematical symbol there. Okay, we're going to try this again. Note to self, avoid the Mankey. Change in anything is final minus initial. That's going to become important. That is going to be worth memorizing, although I'll flog it for a while, because especially in Physics 12, hey, I'll ask you to find the change in voltage. It's the final voltage minus the initial voltage. I'll ask you to find the change in momentum. It's the final momentum minus the initial momentum. I'll ask you to find the change in anything is final minus initial. So as an equation, we have this. Average speed. The symbol for speed, well, the symbol for velocity is v with a vector. The symbol for the scalar version of velocity isn't an s. I told you we hate the letter s. It's the v without the vector sign. Average, I typically use a AV subscript. There is a symbol for it, but I prefer the subscript. And it's going to be, what did you say change in anything was, Kiana? Final. Loud and proud again? So it's going to be your final distance minus your initial distance divided by, and can you go up here for a second? It's also technically change in time, so it's time final minus time initial. You won't, I don't think, see that equation on your formula sheet because we start to take some shortcuts. First of all, time, don't write that down. Write that down, don't circle it. Time, Camille, is very special. Time, by definition, is always a change in, because to measure any amount of time, you have to start and then stop a stopwatch. It's just how it works. That's how time works. And so we get lazy over the years. You're going to see most of the time I don't even bother putting the delta. Leave it in your notes, but you notice I actually forgot to put it in this first time and I had to go back and catch myself because it's always a change in. So we get kind of lazy that way. Anyways, what would the units be? What's the top? What do I measure distance in? Meters per. What do I measure time in? Seconds. It's worth memorizing what units go with what. And as someone who hates memorizing stuff, if I ever tell you that something is worth memorizing, that means that it's really worth memorizing. You awake now, Max? Good. Speed, scalar or vector? It'd be nice if there was some dumb way to remember that. So if you see a number with meters per second next to it, that's a speed, or a velocity if it's a directional component. Turn the page. Average velocity is the change in displacement over the change in time. Where Kiana, what does this triangle mean? Change in, and what's change in anything? Loud and proud? I heard someone say it back there.
Final minus initial.
And it's weird that phrase is tricky to say, but it is. Finus minus, anyway, it is for some reason. So as an equation, the average velocity is going to be your final displacement minus your initial displacement divided by time. Divided by time final minus time initial, but we get lazy because time is always a change in, and so I just wrote the T for the first time this year, and I'll be doing that most of the time this year. Units, also meters per second, but it's a vector, which means usually it'll have a directional component. North, south, or negative, which would imply backwards. Question, Aiden? Yeah. You could go t final minus t initial. So, if the bug's trip mentioned way back in example 1 took 30 seconds, what's the bug's average speed? Well, average speed is going to be the distance over time. Average velocity is going to be the displacement over time. For both of these, the time part is 30. Owen, but not Owen. This Owen. Can you look back at example 1? What was the distance that it traveled? My brain is vaguely remembering 14, but don't quote me on that. Was it 14 meters? And what was the displacement that it traveled? Positive? No, negative. Sorry. Negative. Okay. So, 14 divided by 30. Technically, this 30 right here is 1 sig fig, and so technically I should give my answer to 1 sig fig. We're going to ignore sig figs for the remainder of the year, aside from your quest that you're writing on Wednesday, but I'm not going to try and make up values that always have good sig figs. When in doubt, go to 2 or 3, probably 3 sig figs in your final answer. So 14 divided by 30 is what? And round off properly, please, to 3 sig figs. Alessio, what'd you get? 0.46. So 0.46. We're going to round off properly. We round off. We don't chop off. So 7, yes? If you had written 466, I would take a half mark off. Units. Well, I know it's meters per second because I've memorized that, but can you see it's kind of hidden in the equation? Distance is meters, time is seconds. Of course, it's meters per second. That number is what most people think of as velocity as well. No, it's its speed. Its velocity would be negative 0.2, I think, yes? If you wanted to go to 3 sig figs, you could add a couple of zeros there. Meters per second. On average, it was traveling backwards. Technically. On average. Even though it did spend some time going forwards. Distance doesn't care. Distance just says how many steps did it take, how long did it take to get, okay, that's the distance it traveled. And that's the one that most of us think for speed or velocity. If V average equals displacement over time, so here is the first big skill I want to give you. How many variables does this equation contain? How many other equations are hidden in there then? There's a total of 3 equations hidden in here. And you can memorize each equation. I'm going to teach you how to rearrange equations in your head and derive them. And by doing so, I'll cut down on your memorization about 80%. So you got to buy into this. Some of you will take to this like a duck takes to water, and some of you are going to be, but I'm really going to push this on you. So here's what I wrote. If average velocity is displacement over time, what would be an equation for displacement and for time? Since we're going to find 2 equations, let's draw a little line down the middle. I want to get the d by itself. So I'm going to write down VAV equals d over t, and I'll bring in the vector symbols. What side of this equation is the letter d on? The right? So I want to move stuff to the left. What else is on the same side as the letter d? What's the t doing to the d? Adding, subtracting, multiplying, or dividing? What's the opposite of dividing by t on the right? Multiplying by t on the left. Is that okay? So have I used my lazy but organized phrase already? I'm going to cross the t out. I'm going to tuck it right there to show that I multiplied. And then I'll quickly rewrite this. There's going to be a VAV times t. And then do you mind, look up. Instead of equals d, can I put the d by itself on the left? Because that's typically where we're used to seeing the thing by itself. So I just spun the whole thing, basically. That's an equation for average displacement. So that's an equation for displacement. It's your average velocity times your time. That's what you do if you're driving and you want to figure out how far you've gone. We've been averaging 80 kilometers per hour north. We've been traveling for half an hour, 0.5 hours, 80 times 0.5. We've gone 40 kilometers so far north. Okay. Let's get the t by itself. Where is the t right now? On the, I'm looking for a word that starts with the letter B. Bleh. Bleh. Dealing with variables on the bottom is yucky. Wait a minute. What's dividing by t on the right the same as? Multiplying by t on the? As far as I'm concerned, those are the same equation. They are. But now where is the t? On the top? I want to get it by itself. What else is next to the letter t? What variable? What's the v doing to the t? Adding, subtracting. So what's the opposite of multiplying on the left? So are you telling me, Deegan, that an equation for time is going to be the displacement divided by the average velocity? Yes. And I don't need to memorize it. I can derive it. I think the one that I gave you on your formula sheet is probably that one there, because I tend to give the non-fraction versions of equations because they're easier to work with. Is there a d equals v av t on your sheet? Yeah? Did I give you the v av equals d over t on your sheet? I did, Riley? I'll stop giving you multiple versions shortly. I don't think I gave you t equals d over v av. I'm pretty sure I didn't give you that one. Okay. So here's the point. If you give me any two, I can find the third. Okay? Really, the point of this lesson was to get to example 7 and following. So here we go. A motorist travels 350 kilometers during a 6-hour period. What's his average speed in kilometers per hour and in meters per second? What does this want me to find? So I tend to use an approach for physics that I call Defect. Don't write this down because we're going to put it in our notes in a couple of days. And Defect stands for list your data, find a formula, insert the numbers, crunch or calculate the answers. I have two acronyms that I fall back on. One is DFIC. You don't need to write that down. We'll get it later. And the other one is DULP. DULP stands for Draw a Little Picture. You'll hear me in my Physics 12 classes whenever someone asks me a question. Have you DULPed? Have you DFIC'd? No. Try that first. Also because that way, Owen, your question is no longer blank. You don't have a blank piece of paper staring at you. Trust me, you're more relaxed. Success just goes way up. So using my defect method, this is how I would handle this. What are they asking me to find in part A? Actually, you know what I would do first? I would write down A bracket because I've written something down. What are they asking me to find in part A? Now, this is a word problem, but one of the nice things about physics word problems, unlike math word problems, which are typically pretty stupid and contrived, the physics ones, in math, you're always like, what do I let be X or whatever? Physics, it's pretty obvious what they want me to find. Alessio, in part A, what do they want me to find? What was his? No, what was his? Loud and proud, what? I write this down. VAV equals question mark. That's my way of saying I figured out what they want me to find. Have I written something down? Am I more relaxed? Is success going to go up? Yeah. Then I go through the question and I'm looking for numbers and physics words. What do you mean by physics words? A couple lessons from now, I'll show you what I mean by physics words. What's the first number you see? What are the units next to that 350? Oh, is that time? No, what's measured in kilometers? Yes. Now, these are not the preferred SI units, but that's okay. They did say they want the answer in kilometers per hour, so I'll go with it. I'm going to write down D equals 350. I didn't write the kilometers down. I might. What's the next number that you see? What are the units next to the 6? So that tells me it's a. And the fact that they want the answer in kilometers per hour, and the fact that this is in kilometers and this is in hours, I didn't bother writing the units. I checked and I'm happy with them. Now, if this had been seconds or minutes, I would have written kilometers and I would have written minutes and I would have had to do some kind of a conversion. And those are coming down the pipe. But I'm lazy but organized. I check along the way, and if I don't need to write stuff down, I'm good with that. I'm looking for an equation that has a V, a D, and a T in it. There is one. V av equals D over T. And now it's plug and chug. Normally I would then say I have to get the V by itself. Hey, it already is! What's the distance here, Alessio? What's the time? And you notice, I'll write this in, you don't have to if you don't want to, it is kilometers over hours, which gives me an answer in kilometers per hour. That's how I knew I was good. 350 divided by 6, and then give me the answer to 3 sig figs rounded off properly, please. By the way, technically, 350, how many sig figs? This is good review for your test next class. 350, how many sig figs? 2. 6.0, how many sig figs? 2. You know what? Just for practice, let's go to 2 sig figs as though we did this properly. What do you get? Let's go to 2 sig figs as though we did this properly. 58? Yes? Or 59?
58.
Okay. Keep the number on your calculator. Okay. B. What does B want me to do, Alessio? Same thing, but in. Put your pencils down, look up. Wrong button. That button. What was the answer? Give me more sig figs. 58 point. It repeats after a while. 58.3 repeating? Okay. Don't write this down. Kilometers per hour. I want to convert this to meters per second. Riley, we do this so often, this one conversion from kilometers per hour to meters per second or meters per second to kilometers per hour. We're going to add a shortcut to our formula sheet just this once because this is one we're going to use over and over and over. We're going to derive it. First thing I want to do is get rid of kilometers. Where will kilometers go in my next fraction, on the top or on the bottom? What's going to go on the top? You don't need to write this down. Meters. I'll tell you when I want what you're going to write down in just a second. Okay. And it would be 1,000 meters over 1 kilometer. And I want to get rid of hours. Where is hours going to go in my next fraction? On the top. And seconds. George, how many seconds in 1 hour? Do you remember? So it seems to me when I'm going from meters per second to kilometers per hour, I times by 1,000 and divide by 3,600, or as a shortcut, I think I divide by 3.6. Now that's going from kilometers per hour to meters per second. What do you think I would do with that 3.6 if I wanted to go from meters per second to kilometers per hour? So here's what you're going to do. On the bottom of the front page of your green sheet, let's write this. A little kilometers per hour here, a little meters per second here. Let's write an arrow going this way, an arrow going this way, and divide by 3.6 and times by 3.6. Is that enough for you to figure out the shortcut? Whatever else, I mean, you can do a longer version if you want to. And this is one often kids do end up memorizing because they get sick of looking it up, which again is the only reason you should memorize something, because you get sick of looking it up. But I'll let you add this one to your formula sheet. So kilometers per hour to meters per second. I always memorize, I know that it's something to do with the 3.6, and then I derive the rest in my head because I'm lazy. So, do you all still have that 58.33333333? Okay. I would like you all to find your answer button. If you don't know where your answer button is, this is your chance to ask, because you're going to go answer button and then divided by 3.6. It was 350 divided by 6, 350 divided by 6, which gave you that, and then answer button divided by 3.6. If you can't find your answer button, now is the chance to ask, because if you go 58.3 or 58.33, you're introducing error. The answer button will carry about 100 sig figs for you. It'll be much more accurate, less typing, and less error. Anybody not able to find their answer button, now is your chance to ask. You got it okay, George? Yep. And you get 16.2. So to 2 sig figs, I would go 16. This we'll write down. So B, V, did we divide by 3.6? Okay, so we'll go like this. V av equals 58.3 divided by 3.6. And this is the answer in meters per second. Okay. So I can go from meters per second to kilometers per hour. I prefer meters per second, but if I'm going to do applied questions with you with cars, car speedometers are not in meters per second, so I'll often give you the data in kilometers per hour so that you have it in context that you're familiar with. Example 8, I like example 8, I like example 8, I like example 8, example 8 is a nice question. Why would I say that? Did you hear me say it's going to be on the test? You're the kind of student that just notices when a teacher tends to emphasize things? Good. Okay. How many of you have ever stood where there was a great echo, somewhere where you had like about a 2 or 3 second delay before you heard it coming back? Okay. Ever wonder how far you're bouncing off? You can calculate it. Or if you know how far you're bouncing off, you can figure out how long it'll take, vice versa. Speed of sound is 330 meters per second. That actually is slightly inaccurate. The speed of sound depends on altitude, humidity, temperature, but roughly 330 meters per second. Sheldon is shouting at the base of a steep mountain. If the mountain is 420 meters away, how long will it take before Sheldon hears his echo? What's this question asking me to find? Let's write down T equals question mark. What's that 330 then? Someone said distance, someone said V. One of them's right. What are the units next to that 330? Is distance measured in meters per second? You starting to see why I said it's worth memorizing what units go with what? What's measured in meters per second? This is a speed. Also because it said speed, but even if they hadn't said that, I would go, it's got to be a speed. By the way, I did a quick check. Are all of my units in meters and seconds and nothing in kilometers or hours? Then I'm not going to write the units. They're already in good shape. What's that 420? How do you know? Meters. Looking for an equation that has a D, a V, and a T in it. I think the one that I gave you on your sheet is this one. D equals V av T. Yes? How would I get the T by itself? Well, what's the V doing to the T? Adding, subtracting, multiplying, or dividing? So how do I move it over? So you're telling me that I would go that? So I'll have this. T equals D over VF? Yeah. New equation. I'm not going to memorize it. I can derive it. 420 divided by 330, which is what? You get 1.272727272727. For a candy, who can tell me why this has to be wrong? because it is wrong. Yeah.
Because when the sound goes to mid-target bounce back.
You hear him? We've just calculated how long it would take the sound to get there. But for an echo to work, it's got to come. So what would I do with this?
2.
Okay. So I'm going to write 1.27 repeating, and then I'll just put times 2. I'm going to go answer button times 2 because it's less typing and more accurate. And I get 2.5454. How many sig figs should I go to in this question? Technically. 330. How many sig figs? 2. How would I, if I'd wanted that to be 3 sig figs, what would I have written? 330 with a decimal, yes? And 2 sig figs, so 2 sig figs, so you know what, 2.5 seconds. Good. Good. The more interesting one is if you are somewhere where there's a good echo, and you have your smartphone with a stopwatch, if you time the echo, it's going to be 330 times the time, and you can say divide by 2, because the time is twice as long, and you can figure out how far away the cliff is. I really got to figure this out here. That's too handy for you. Make sure the wrappers get in the garbage. Yep. Example 9. Jeremy is driving at 18 meters per second. If he drives for 2.5 hours, how far will he travel in kilometers, in meters? Why is this question yucky? Yeah. Units don't match. Yeah, first thing I noticed, meters per second, like hour, So, this wants how far he will travel in kilometers and in meters. I think what I'm going to do is I'm going to convert this to kilometers per hour, which, if I recall, has something to do with a 3.6. Okay? And then that'll give me an answer in kilometers. And then from kilometers to meters is fairly trivial. It's something to do with 1,000. I either times or multiply. I'll figure that out. Times or divide. I'll figure that out. So since there's an A and a B, I'll go like that. Part A. How far? D equals question mark. What's that 18? But that's the one that I don't like. So this time I'm going to go V equals 18 meters per second. I'll write down the yucky units. How do I convert that to kilometers per hour? Is it times by 3.6? So I'll go times by 3.6 equals, I think I need a little more room. And this I won't round off to any sig figs because I want to reuse it. 64.8. Kilometers per hour. What's that 2.5? How do you know? Looking for an equation that has D, V, and T in it. Right now, you really only have one equation, but by the end of this week, you'll have 4 to pick from, and it'll be a little trickier, and we'll build on it. So I think all I have right now is D equals VT. And this is an average speed. So it's going to be 64.8. I'm going to use my answer button times 2.5, which is what? $162. Anybody else? Yep. Units? Kilometers per hour? For a distance? Just kilometers, right? How many meters is that? Have you guys figured out the shortcut to go from kilometers to meters? Times by? Okay, so D equals 162,000 meters. I didn't write down what they gave me and do a full unit conversion with the fractions. I know how to go from meters to or kilometers to meters or meters to kilometers. Example 10. True or false? An object can have a positive distance while having a displacement equaling 0. You know what? We're going to vote. How high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting because Mr. Dewick will make fun of me if I don't vote, and Mr. Dewick will make fun of you if you don't vote. So here's the question. An object can have a positive distance while having a displacement equaling 0. True or false? Well, you think for a few seconds. Who says true? 2, 3, 4, 5, 6, 7, 8. Who says false? Who didn't vote? I know. What are you voting? You're going false. So we went, true was everyone minus 1. False was, oh, wrong question, sorry, up 1. Everyone minus 1, and false was the minus 1. Convince me. So you can either attack someone else's answer as being wrong or defend your answer as being right. Max?
So, like the bug walked forward and then back, you still have positive displacement. You still have positive, like, distance walks. So if you walk forward and then back to the place you started.
Oh, okay. So how about this? 3 meters forward, 3 meters back. 1 meter forward, 1 meter back. But there. Distance would be 6. Displacement would be 0. Okay. So circle true. Example 11. An object can have a positive distance while having a negative displacement. Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. Who says true? Yeah. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I love Annika. She hates getting stuff wrong, so this was her vote. Just the hand twitched. What did I say, 15? Who says false? Those of you that didn't vote false. Come on, commit. 1, 2, 3. Some of you didn't vote. I'll get you next time. Convince me. Yeah, Aiden.
Because if I was walking forward and backwards.
Can you give me some numbers?
Sorry, say I walk forward 5, and then 5 meters forward, and then I walk back 2 negative. It's still I just said muted. It's still
2 negative.
Or the 2 meters backwards. Or 2 more than 2, 7. Sorry.
Okay, because I was going to say your initial example wasn't.
My bad. Instead of meters backwards, I'm still moving.
What's your distance? 12. What's your displacement?
-2.
Distance is 12, displacement is negative. Does that satisfy example 11's statement? Okay, true. I agree. Example 12. True or false? An object can have 0 distance while having a positive displacement. Once again, without blurting out an answer, we're going to vote without blurting out an answer. Once again, how high you hold your hand up is how sure you are of the answer. So an object can have 0 distance while having a positive displacement. Who says true? Was that a vote or was that just scratching the hair? Oh, just adjusting. Number 93 was out of place, so there you go. It's good now. Who says false? unless we define the number 0 to be positive, but I don't think it is. Okay, I agree with you. One of my favorite comics is the comic strip called Foxtrot. The author, Bill Ammond, actually has his physics degree. And while he was in university, he was often doodling, and some of his friends said, "These are funny, you should publish them." So he often publishes mathematically or physics-wise accurate comics. Foxtrot looks at a family, and there's a younger brother named Jason who's the physics nerd and the math nerd, and of course dear to my heart. So Jason, the younger brother, is playing football with Peter, his older brother. And Jason says this, "Okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards, then turn right and go 25 yards, then turn right again and go 30 yards, then turn right and go 30 yards, then turn left and go 10 yards, then turn left and go 15 yards, then turn left and go 20 yards, then turn left and go 50 yards, and I'll hit you with the ball." Peter thinks and he says, "Won't I be right back where I started?" Jason says, "I can't throw very far." Okay, here's a new play. I never get to be quarterback. What distance will Peter run in order to complete the play? Well, it's going to be 40 plus 20 plus 25 plus 30 plus 30 plus 10 plus 15 plus 20 plus 50, which is what? I can do this in my head. 60, 85, better yet 90, 115, 145, 155, 165, 170, plus 240. Double check me. Am I right? I might be wrong. The answer 240? Yeah. I can do math in my head. And that's yards because it's a U.S. football thing. What will Peter's displacement be? What? 0. Yeah. So what's your homework? Number 1. Number 2, in question number 2, assume each square is 1 kilometer. So if you move 2 squares, that's 2 kilometers. If you move 3 squares, that's 3 kilometers. Number 3, I noticed when I photocopied this that the XI wasn't very visible, so that's why I have a little letter I pointing. That's the initial right there, and that's the final right there. I think in your copies you can't actually read the typed subscripts very easy, so I hand wrote that on top. Number 4, yes, I'm stealing questions from the internet. 5 is good. 6 is good. 7 is good. 8 is good. 9 is good. 10 is good. And the answers are on the last page. Mr. Duke, why don't you just say do all of them? Because I wasn't sure if I was going to give you all of them. Your first bit of homework to work on is the review and the take-home quiz. And I think for now, for today, because I've given you 3 things to work on, I'm probably going to press pause for a while. Okay? You have class to work on stuff.